Okay, here's example problem 8 from homework number 2. And this one is talking about IPv6 addresses and trying to make the point just how many there are. It's 128 bits or 16 bytes long. And it asks about changing your IP address 10 times per second. And so what we're going to do is we're going to say 10 times per second times 60 seconds in a minute times 60 minutes in an hour times 24 hours in a day times 365 days in a year. And this is going to give us 315 take a sip of coffee there, 360,000 IP addresses per year. So if we changed our IP address uh, 10 times per second, okay, or 3.1536 times 10 to the 678th IP addresses per year. Now the question is, how many bits does this take to specify this? Well, in general, we can take the log base 2 of any number, including this one, and that's going to tell us how many bits it takes to represent that number. And here we get 28.2, and so this implies that it takes 29 bits per year per IP address if they're changing 10 times per second. Okay, in the same way that I take the log base 2 of 64 and I get 6, it takes 6 bits to represent the numbers from 0 to 63. It takes 7 bits to represent 0 to 128 or to 127, etc. If I take the log base 2 of any number and round it up to an integer, it tells me how many bits it takes to represent that number. So it takes 29 bits. And now what we're going to do is we're going to do this with 100 billion hosts. 100 billion hosts. Okay? And 100 billion hosts, let's see, this is going to now be, it's going to take more bits for all of those hosts. And what we'll do is we're going to do log base 2 of 100 times 10 to the 9th. And that's going to tell us how many more bits. And this is 33.2, so it takes 34 bits for the hosts' IDs. Okay, so it takes 34 bits to specify one of 100 billion hosts, 29 bits to allow those IP addresses to change 10 times per year. And finally, so the total number of bits is the 29 plus 34, which is 63 bits. It's just about half of the length of the IPv6 addresses. Okay, and so that implies that we have 65 bits left. Okay, and if we want to know how many years we can go on this way, 100 billion hosts, each host changing their IP address 10 times per second, means that we can go 2 to the 65 years, like this scheme. And that's approximately equal to 3.7 times 10 to the 19th years. Longer than the universe has been around by a big, long shot. So there's a lot of IPv6 addresses. So I hope that helps with that problem.